Yeah, that splotch here. So it's really probing basically the earliest structures we know in the universe.
When you look at this image, there are lots of splodges all over the place. What made you look at that one in particular?
We have been seeing this object already in the very early data we obtained nearly 2 years ago.
The James Webb Space Telescope is a beacon of human curiosity and technical capability in the immense expanse of the universe, where mysteries abound and the unknown extends forever. Hailed as the most sophisticated space observatory ever made, this groundbreaking device promises to reveal mysteries about the universe that have long defied human understanding. However, what if the very findings it produces are so remarkable that they call into question the basis of our knowledge? Imagine looking back into the early cosmos and discovering objects so dazzling and mysterious that they contradict modern cosmological models. Rather than merely the faint glimmers of old stars, prominent astronomers and Nobel laureates are raising the alarm, calling these results disconcerting and frightening. The consequences are significant. They call into question accepted hypotheses about the universe's early history and force us to reassess our whole understanding of the world. What precisely has the James Webb found out? How could the basic foundation of our scientific beliefs be called into question by these seemingly harmless patches of light? As we investigate these issues, we set out on a quest that not only expands our understanding but also makes clear how constantly changing science is. Come along as we investigate the depths of these findings, the ideas they challenge, and the future they hold. Let's take a look back at Christmas Day 2021. The day the James Webb Space Telescope was launched. Inspiration arrived that day. Together with the European and Canadian space organizations, NASA engineers conceived and constructed the James Webb Space Telescope. At $1 billion and 6 tons in weight, it is the biggest optical telescope ever launched into space. The Earth and French Guiana shook early on December 25, 2021, when the rockets on the Ariane 5 launch vehicle ignited. The James Webb Space Telescope began its month-long trip to its present location about 93,000 miles, 1.5 million kilometers, from Earth. With a roar, the 6.5-meter telescope was worth the extra 5 months it took for engineers and scientists to prepare it for use. Just 2 years after its introduction, James Webb has completely changed the way we see the cosmos. After 2 decades of development, the James Webb Space Telescope has finally been launched, and in the short time since then, it has provided scientists with fresh insights, inspired the public with mind-blowing photos, and opened our eyes to the limitless potential of the cosmos. Press the follow button right away because we're about to reveal a startling reality that scientists find worrisome. Examine this picture. Researchers have revealed that this newly discovered early galaxy, formed some 13 billion years ago, is far bigger and more developed than predicted for a galaxy from the early universe. Webb has previously discovered similar galaxies in the early cosmos. The Webb telescope has presented challenges to our accepted ideas of cosmology ever since it set out on its mission. There is more to come from this incredible telescope. Once again, the telescope has shown us something unsettling about the cosmos. A Nobel Prize-winning physicist recently stated that the James Webb Telescope has demonstrated how incorrect our knowledge of the cosmos is. Yes, it isn't about big, brilliant galaxies this time, but rather some fresh, significant data from the James Webb Telescope have upended long-held beliefs in cosmology. Think about this. A fundamental tenet of cosmology is that matter is evenly, isotropically distributed across the cosmos. That is, if you stare far enough away, everything appears the same in every direction. This is clear from the fact that during the evolution of the initial matter field produced by the Big Bang, there are no observed disparities in the large-scale structures, as the forces are predicted to work uniformly on vast scales throughout the universe. Everywhere you look, the temperature and matter density are the same, and the universe is expanding uniformly. Assuming that our universe is uniform in all directions, scientists have been developing cosmological models for more than a century. This premise also forms the basis of the Big Bang model, the best explanation for the cosmos. It is also demonstrated by the cosmic microwave background radiation that the cosmos is uniform throughout. However, recent research published in the Astrophysical Journal Letters on February 6 raises the possibility that this assumption may be seriously flawed. Recent discoveries by astronomers have demonstrated that our universe is expanding at different rates in different parts of the universe. In this study, they disclosed that the rate at which the universe is expanding varies based on our location. This is a serious issue as it would challenge astronomers if the cosmos is growing at various rates in different regions. Additionally, this new research raises the possibility that our existing estimations of the universe's age and composition are wholly inaccurate. Nobel laureate David Gross adds, "We wouldn't call it a tension or a problem, but a crisis." Let's examine this finding in more detail and see how the recent Webb telescope finding validates a cosmological catastrophe. The first empirical proof that the cosmos is expanding overall was presented by Edwin Hubble in 1929. He found that a galaxy appears to be vanishing into space more quickly the farther it is from us. Using the telescope available at the time indicated that the expansion of the cosmos is uniform in all directions. Scientists concluded from this finding that the universe must have a limited age, since if it is expanding, it had to have begun at some time in the past. Furthermore, because expansion occurs uniformly throughout the universe, the age of the cosmos may be determined by precisely measuring the rate of expansion, or the Hubble constant. However, there was a great deal of doubt over the Hubble constant, or the rate at which the universe is expanding prior to the Hubble Space Telescope's debut. This number is required to determine the universe's age, approximate its billion-year development, and comprehend the forces that govern it. The cosmos may be as ancient as 19.5 billion years, or as young as 9.7 billion years, according to data from the Hubble Space Telescope. Unfortunately, this lower number suggested that the cosmos was younger than the oldest stars known to exist. Surprisingly, every technique astronomers have employed to determine the precise amount of the expansion rate across the ages yields a different result. It appears as though the expansion of the cosmos varies depending on the observation. There are now two accepted ways to measure the Hubble constant. The first technique involves sorting through minute variations in the cosmic microwave background, formed only 380,000 years after the Big Bang and a remnant of the universe's first illumination. Using the European Space Agency's Planck spacecraft, scientists studied this microwave haze between 2009 and 2013, deriving a Hubble constant of around 67 kilometers per second per megaparsec. The second approach uses a Cepheid variable star or supernova as a distant source. Astronomers can determine the absolute brightness of Cepheid stars because they pulse more slowly as they become brighter. By comparing this brightness to the observed brightness, we can determine how quickly the cosmos is expanding. However, this is where the enigma begins. When compared to Planck's observations, the Cepheid variation data show that the universe is expanding at a very high pace of around 74 kilometers per second per megaparsec. At first, several experts speculated that measurement error might be the cause of this disparity. However, as of late, James Webb Space Telescope images confirm that earlier measurements are accurate and that the universe is expanding differently in different places. Additionally, Adam Rees, a physics and astronomy professor at Johns Hopkins University, stated, "We have now covered the entire range that Hubble observes, and we can rule out measurement error as the cause of Hubble stress with very high confidence. The cosmos may not be the same everywhere, as shown by this variation in the universe's expanding rate. If this is the case, then variable estimates of the expansion rate cannot be used to determine the age and size of the universe, which leads to the collapse of our mainstream cosmological model. The first inquiry that emerges is the reason behind the universe's varying rates of expansion in various regions. The fact that dark energy, the enigmatic component thought to accelerate the expansion of the cosmos, is not uniform may be one intriguing explanation. To put it another way, differing expansion rates are caused by varying strengths of dark energy in different regions of the universe. According to scientists, The incomprehensibility of the principles of physics as they are understood is implied if the cosmos is not homogeneous and isotropic. It's possible that well above the cosmic horizon, light travels more slowly than at walking speed, gravity reverses, and unicorns exist. An intense discussion among astronomers has been triggered by this recent finding made by the James Webb Telescope. The cosmological principle, one of the pillars of astronomy, is called into question by the universe's uneven expansion. How do you feel about the aforementioned event? Share your thoughts in the comments section below, and please subscribe to our channel. Together, we will talk about this matter. Now, keep your eyes on the screen and join us as we examine the incredible discoveries made by the James Webb Telescope throughout the last 2 years. First up, exposing the Crab Nebula. The Crab Nebula, located in the Taurus constellation, is a picture of cosmic activity taken by Webb's NIRCam. Because we're used to maps of the Earth, the compass on this picture could appear reversed, but it's actually a map of the sky, and we're gazing up into it. This massive size, expressed in light years, equates to the 588 trillion miles that light travels in a year. The light in this picture started its journey 6,500 years ago and traveled across space and time to get to us. The picture spans a distance of 10 light years. A pulsar, the remnant of a supernova, spins quickly and flashes like a lighthouse at the center of the nebula. Not only is the Crab Nebula, or M1, an extraordinary cosmic relic, but it is also the source of fresh ingredients that form planets and life. We are witnessing a portion of the universe's ongoing cycle of death and rebirth in this 5.5 arc-minute wide image, showing how creation and destruction are intertwined in the universe. Number 2. Max J0416. Look at the picture of Max J0416, a large galaxy cluster that causes light to bend around it. This cluster provides two views of the same cosmic wonder, one from Hubble in visible light and the other from Webb's NIRCam in infrared. Although the compass arrows appear reversed here, they are in the correct position since they represent the sky as seen from Earth. The complete image spans a little more than 2 arc-minutes in width, a small portion of the immense canvas that is the sky. Even though it's a small angle, it sums up a vast amount of the universe. This cluster, officially designated Max J0416.1-2403, is located in the constellation Eridanus. It acts as a gravitational lens, distorting space to amplify and distort the light of the galaxies behind it. This cosmic magnifying glass allows one to see galaxies that would otherwise be hidden. These clusters not only make for amazing photographic subjects, but are also essential to understanding the universe's mass distribution. Lastly, Max J0416 and the remarkable mysteries it holds reveal a unique galaxy cluster that acts as a massive cosmic magnifying glass. It bends light across the ages, unveiling a far-off galaxy that sprang into being 3 billion years after the Big Bang. Among this galaxy's stars is a remarkable one that has enthralled scientists with its brightness. Astronomers have affectionately called Mothra. This star is not like the others. Mothra is a dazzling beacon that has come to meet us after traveling across time and space with light magnified by almost 4,000 times. However, what is the source of Mothra's remarkable luminosity? It's the combined might of Max J0416 and an enigmatic lens, a globular cluster, a dense astronomical object with the mass of a swarm of stars. This finding, tucked away in the constellation Itis, is not only proof of the glories of the cosmos, but also provides us with an exciting lead as we continue to piece together the nature of the universe's hidden mass. Every tiny light in the great darkness tells a tale, and Mothra's is one of old light that has persevered through the years and reached us in spite of all the difficulties. What other possibilities exist, just waiting to be brought into sharp focus? Such dramatic stories abound in the cosmos, of which Max J0416 is but one episode. Number 4. Thorium from a star merger. Webb's groundbreaking discovery of this uncommon element in the universe is akin to finding scientific gold, or rather thorium. In a cosmic tale of epic proportions, two neutron stars, leftovers from stellar explosions, performed a gravitational tango in a far-off galaxy before they finally merged in a catastrophic event, weaving their tale together in the vast fabric of the cosmos. The finding started with two stars in a spiral galaxy far beyond our own, pulled inexorably toward one another by gravity. Neutron stars are extraordinarily dense celestial objects that remain after a star explodes in a supernova. These stars set off on a cosmic voyage, propelled by their explosive births, and eventually collided after several 100 million years. A tremendous cosmic light display, a gamma-ray burst known as GRB 23307A, which is so intense it emits light equivalent to thousands of suns, was made possible by this violent merging. Initially detected by the Fermi Gamma-Ray Space Telescope, GRB 23307A is notable for being the second most brilliant gamma-ray burst humanity has ever witnessed. Scientists were able to determine the source of these neutron stars and observe the consequences of their merging thanks to Webb's infrared capabilities. In the kilonova glow, Webb saw evidence of thorium, an element that is less common on Earth than platinum. This is the first direct observation of such a heavy element following a neutron star collision. What's the significance? It is now established that kilonovae are cosmic forges that create the heaviest elements in the cosmos. The discovery of thorium by Webb is only the start. With the discovery of these new cosmic mysteries, astronomers may soon learn the origins of the constituents that make up our surrounding environment. This discovery adds to our knowledge of the cosmic life cycle and raises the possibility that there are yet undiscovered riches hiding in the deep darkness, just waiting for Webb to unearth them. Number 5. The faraway lighthouse disclosing a prehistoric black hole. With the powerful Chandra and Webb satellite telescopes, astronomers have been able to see a black hole from the early universe across the width of space. This black hole, which shines from the UHC-1 galaxy, is the most distant black hole ever observed. It was discovered by its X-ray whispering. These X-ray emissions are the telltale signs of a supermassive black hole that is constantly consuming more material from its surroundings and expanding in size. The galaxy cluster Abell 2744, which the James Webb Space Telescope captured in infrared, serves as the backdrop against which the black hole's tale is told. This cluster, also known as the Pandora Cluster, is a collection of galaxies whose light has traveled billions of years to reach us. It is considered a cosmic crossroads. Upon exploring Webb's infrared image, we see a vast expanse of darkness flecked with far-off suns and galaxies spiraling and stretching over the emptiness. Are these specks of white, orange, and purple light not just points but entire galaxies, each with a unique story to tell? A little orange speck, 13.2 billion light-years distant, appears to be insignificant yet is a beacon from the past. Within this group of galaxies, a supermassive black hole in the galaxy UHZ-1 is located on that speck, providing a unique window into the early stages of the life of such cosmic giants. This image is more than simply a picture. It provides a glimpse into the early cosmos and hints at the formation process of the first supermassive black holes. This image shows a young cosmos with a black hole that has developed over billions of years. It serves as a powerful reminder of both the size of the cosmos and the unsolved mysteries surrounding its beginnings. Astronomers believe that before James Webb, galaxies were only little clouds of gas, dust, and stars that eventually developed into the island universes we see today. However, the telescope can see infrared light, which enables it to see deeper into space and consequently further back in time to the formation of galaxies. These children, which date to within 500 million years of the Big Bang, have been discovered by James Webb, and they are far brighter than anyone could have predicted. The galaxies may be more productive than expected in producing stars, creating huge stars more frequently, or perhaps most intriguingly, being more massive than previously thought. In some spiral galaxies at cosmic noon, when the universe was between 2 and 3 billion years old and star formation was at its peak, scientists have also discovered more sophisticated structures. Apart from producing incredible findings, James Webb collaborates with other observatories to provide breathtaking visuals, such as the ghost galaxy M74. Early black holes, specifically supermassive ones, were discovered using the Chandra and Webb satellite telescopes. Astronomers identified the most distant black hole yet observed in X-rays, located in a galaxy known as UHC-1. These supermassive black holes, which haven't had much time to graze on their surroundings, are surprising to find lurking in the early cosmos. Black holes are known to expand as they consume passing stars, clouds of gas, and dust. Several black holes, weighing around 1 billion solar masses and existing 800 million years after the Big Bang, have been found by the James Webb Telescope. More significantly, the telescope has detected even smaller SMBHs at earlier periods, with masses ranging from 1 million to tens of millions of suns. This could provide scientists with enough information to understand the evolution of these massive objects. Dust in the youth of the universe is another significant discovery. James Webb recently focused on a young galaxy known as JD1, where the powerful telescope detected potentially unexpected signs of molecules at such an early stage of cosmic time. Dust, all around us, may be seen in the form of fluffy bunnies hiding under our beds, ominous clouds obscuring our view of the Milky Way, and fingerprints seen in the spectra of far-off galaxies. Since most dust includes carbon, a relatively late element in the universe created by early stars from their first supply of hydrogen and helium, its early discovery is noteworthy. Barely 1 billion years after the Big Bang, James Webb discovered dust in a galaxy due to its distinct chemical fingerprint. The dust may be a mixture of granules resembling diamond or graphite formed in the first stars, providing fresh insight into how galaxies originate and how dust is produced. A closer look at star formation was given by the Rho-Ophiuchi cloud complex, the nearest star-forming zone to Earth. Dense clouds of gas and dust are where stars develop, but dust obscures visible light, making a large portion of the process invisible. However, infrared radiation, which James Webb observes, penetrates dust, providing a fresh perspective on star formation. For instance, it has uncovered hundreds of new stars that Hubble was unable to see, hidden deep within the Eagle Nebula, M16. Additionally, James Webb revealed amazing detail in a portion of the neighboring Rho-Ophiuchi complex. Numerous young, low-mass stars have been seen in the telescope's photos, along with the jets they release that illuminate nearby molecular hydrogen clouds. A dusty relic of a supernova, the supernova remnant Cassiopeia A, was seen by NASA's James Webb Space Telescope using the MIRI mid-infrared instrument and NIRCam near-infrared camera instruments. Earth first saw light from this exploding star only 340 years ago. The remnant of the supernova, called Cass A, is currently seen as a debris disk 10 light-years in diameter. Wispy tendrils of gas and the gentle light of heated dust are responsible for Cass A's breathtaking beauty in the infrared. Astronomers are intrigued by the dust because it is a fundamental component of planets and life. Although earlier research was unable to explain the quantity of this material observed in early galaxies, they believe the majority of cosmic dust originates from the heavy materials supernovae release. Scientists anticipate learning more about the formation of Cass A and other supernova remnants via James Webb observations. In a magnificent and unexpected discovery, James Webb found jumbo, or Jupiter-mass binary objects deep in the core of the Orion Nebula, M42. These jumbos, a binary partner to at least 40 planet-sized objects, defy all predictions. While many stars are known to have companions, planetary mass objects were not thought to be among them. These objects are too tiny to be produced by any current star formation hypothesis, and if they originate in circumstellar disks like planets do, they shouldn't be able to withstand a violent ejection. It's conceivable that astronomers will have to update their theories regarding the formation of stars and planets, or devise a new explanation for the genesis of these jumbos. A revolution in molecular exoplanets is underway. Based on scientific facts, This artist's concept illustrates what exoplanet K2-18b may look like. Located 120 light-years from Earth, it orbits the cool dwarf star K2-18 in the habitable zone. Spectroscopy is an important tool for James Webb studies, even though photos often receive the most attention. It enables scientists to examine the chemical makeup of celestial objects and calculate the redshift, thereby determining the distance of distant galaxies. This is particularly crucial for studying exoplanet atmospheres, as James Webb can identify chemicals invisible to the human eye due to its infrared capabilities. Among its numerous findings, James Webb has detected dimethyl sulfide, carbon dioxide, and methane in K2-18b, a rocky planet in its star's habitable zone that may have a surface ocean of water. The Ring Nebula, M57, in Lyra, one of the most exquisite planetary nebulae, has been examined in stunning detail by NASA's James Webb Space Telescope. The Ring Nebula, the final stage of Sun-like stars, contains 20,000 molecular hydrogen clumps. However, what genuinely distinguishes M57 in James Webb's photos is a set of 10 concentric arcs extending beyond the main ring's outer boundary. Scientists believe these arcs originated close to the dying star as a result of gas expelled interacting with a low-mass companion orbiting at a distance comparable to that of the Sun and Pluto. Exploring subsequent protoplanetary disks, James Webb has provided detailed images of the Orion Bar, a region in the Orion Nebula. The biggest picture, taken with Webb's near-infrared camera, NIRCam, and mid-infrared instrument, MIRI, focuses on a smaller region housing the young star system D203-D506. This system's combined NIRCam and MIRI image reveals protoplanetary disks where planets form around newborn stars and gaseous dusty disks. Webb studies have not only shown unprecedented levels of detail in these disks, but also yielded intriguing hints of life's ancestors. For instance, it discovered 3 nested bands of heated material around the star PDS-70, suggesting planets sculpted the disk in the inner region. Additionally, the detection of water vapor indicates that any terrestrial planets forming there would have access to water. James Webb also found the methyl cation in the protoplanetary disk around young star D203-D506 in the Orion Nebula. This chemical is likely crucial for interstellar organic chemistry and the origin of life. The telescope's amazing findings have shed light on the universe's dark ages. The data and images gathered challenge current theories about the origin and development of galaxies and stars while revealing the universe's most remote reaches. Nobel laureates have highlighted the shocking reality of these observations, which pose fresh questions regarding the universe's formation and early stages. These discoveries are not only a major advancement for science, but also a reminder of the mysteries that remain unsolved. That's all the information we have for you today. Share your opinions and enjoy other exciting space videos.